So you want to simplify a complex number. Well, let's see how we can do this purely in the calculator without any extra work. So obviously, if you want to do it algebraically, we would have to multiply by a conjugate. We won't get into that here. But if you want to do it in the calculator, what if I did type it in just blindly? I can just type in 2 plus 3i. The I is under the dot key, and then divided by 4 minus 4i. Now when I hit enter here, it gives me the answer. So if I check the mode and look down here, there is a couple of options. There's real, a plus bi, and re to the I theta. You can choose what form you want. So if I quit out here, you'll notice we directly have the answer already, negative 0.125 plus 0.625i. And if you want to put that into fraction, I would recommend you go to math, math, and then fraction. Don't need to do num. And then just go there, and that gives you negative 1/8 plus 5/8i. Sweet. Now, what's going on with the mode here, though, that I showed? Now, if I wanted to, I could just go down here and change it to a plus bi. Now, this doesn't really do anything for the TI-84. However, some calculators will not even let you enter it unless you change it to a plus bi form. So if I hit enter here again, it really doesn't change anything because it allows me to do it. But if I change it to re to the I theta version, that's going to be polar form, and it will just directly convert it for me. So it just directly converts this. I'm doing the fraction, so it kind of makes it a little tricky there. But in this case, we just get 0.637 whatever e to the 1.768-ish, just call it that, I. And so now you can just do it 100% in your calculator. You don't have to do, well, anything algebraically. Let's take a look at one more just to make sure we know what we're doing here. This one, where we have 2e to the I pi over 4 divided by 1 plus 2i. This mixes both polar and rectangular forms, but it doesn't matter. We can just type it into our calculator blindly. So I'm just going to clear it out so I can see a little better. 2e to the I, remember that's on the dot key, and pi over 4. When I hit enter, it puts it directly into polar form. So that's 2e to the 0.785. If you want it into rectangular form, we're just going to have to go back to the mode and go down here to the rectangular version, or in this case, I could do real, but I'm going to do a plus bi and just hit enter again, and it will just convert it. So that's 1.414 plus 1.414. I'm assuming that's just 1.414i. Yep. Now, if you want this in exact form, it's a little bit trickier. Notice that I could divide by the square root of 2, because I noticed that 1.414 is the square root of 2. If I divide by the square root of 2, I get 1 plus I. So that means this is root 2 plus root 2i. But you kind of have to recognize that to get it. But in any case, we can find rectangular or polar form without using anything except our calculator. We don't actually have to understand any of this. In fact, just to demonstrate one that you probably may not know how to do by hand, what if I did something crazy like the square root of I raised to the I power? I had to really think about this. How would you do this algebraically? Well, turns out we can just type it in, square root of I, and I'm going to raise it to the I-th power, which is actually 0.46-ish. That's a real number. That's crazy. How is that a real number? Well, just so you know, that's because we can convert this to a polar form, which is e to the I pi over 2 to the 1/2, so I pi over 4 raised to the I, and that's e to the negative pi over 4. That's how you would do it algebraically, just for fun. You don't really have to know that if you're looking into this for just a calculator, but that's why it's a real number, because i's cancel out. But now, you know how, for just about anything you could type in, we can just type in any imaginary number and either get it into rectangular, polar. You don't have to worry about multiplying by the conjugate or any of that nasty stuff. You can just get it in the calculator.